Let's look at question number 5 in the final exam for Everyday Math Demystified, 2nd edition, pages 234 and 235. It shows us a figure exam-1, which I have reproduced here in somewhat truncated form. We have two sequences of numbers, 0, 1, 2, 3, 4, and so on, and -1, -2, -3, -4, -5, and so on, forever. That's what the three dots mean, that it goes on without end. As long as there's nothing to the right of those three dots. If we had like 100 to the right of these three dots and -101 to the right of those three dots, then we would just mean that we fill in the individual numbers that would go in between if we wanted to write out the whole list. But if we have three dots, if you ever see three dots like that and there's nothing beyond them, it indicates that the sequence, whatever it is, goes on forever. And then it shows a correspondence, a one-to-one correspondence like that. Well, what is this a one-to-one correspondence between? I mean, what are these called and what are those called? Well, the correct choice to this question is A. These are the non-negative integers. Integers meaning whole numbers could be either positive or negative, but in this case they are all of the integers except the negative ones, non-negative. Now if we were to talk about the positive integers, we would only be referring to those. When we include 0, sometimes people call those the natural or whole numbers, and there's some inconsistencies in the texts about what natural and whole numbers actually mean, whether they should include 0 or not. So to avoid that confusion, if we call them the non-negative integers, then we are just fine. We know exactly what we're talking about. These are the negative integers, or the strictly negative integers. Now if we included 0 in this, then we'd have to be talking about the non-positive integers. But as things go, these are the negative integers. So it's a one-to-one correspondence between the negative integers and the non-negative integers. And it's a one-to-one correspondence because we can just keep pairing these off forever and ever and ever. In mathematics, infinity, or we better be careful about talking about infinity. That's a whole nother ball game. But things can go on forever in theory in the wonderful world of mathematics.